Okay, so let's start with the class, right? Hi guys, hi, welcome to NEET World Institute and NEET World YouTube channel. Yes guys, so in today's session we are going to concentrate on the problems of the first year EAPCET. Like once we have completed the first year's chapters, right? So once we will see the problems, and once the problem has been done, we can go on with our the second year chapters. Okay, so the first question of this today's class is, if a stone of a mass 0.5 kg is tied to one end of a wire is drilled in a circular path of a radius 2 meter. Okay, so what is the given terms first? I'll write that. Okay, so given, what are the given here? Mass m is equals to 0.5, right? No, and then how much, like it is 0.5 kg. Please try to make note of this units also. So because of this unit, the total problem answer will be going wrong. Okay, and whirled in a circular path of a radius of the circle is given as 2 meter. So a stone in a circular path of a radius. So try to adjust my drawing, guys. Okay, I am not good at drawing. Okay, yes, so this is the thing, this is my radius with the speed, like speed how much they have given. When we are talking about a circular path, the speed is nothing but the angular speed, right? No, angular speed omega is equals to 40 revolution per minute. One revolution is nothing but one revolution, complete revolution, 2 pi per minute, like 60 seconds. Okay, so 40 into 2 pi divided by 60. Got it, na? So 0 and 0 will get cancelled off. 2 times 3 times, which is nothing but 4 pi by 3. How much? Yes, it is seconds, meter per seconds. Okay, so 4 meter per second. Now what is the thing they have given? Like in a horizontal plane, tension in the wire is nearly tension. So guys, when we talk about a tension, no, in this the force will be towards the center, centripetal force. So F, force or tension, T, both are same, like the force or tension, whatever the term we are using, right? So will be equals to mr omega square, mr omega square. Okay, so this is the formula. So can you give answer for this question now first? Done? So what is the option? Option C. Okay, you are saying option C is the answer. Okay, we will mark that answer. Let's solve here. So it is 0.5 into, what is the radius? 2 meter into, right? No, 2 meter into, what is omega? 4 pi by 3, right? 4 pi by 3 the whole square. So when we talk about this, 0.5 into 2 is 1. Okay, fine. Next, what is the thing? So next is 4 by 3 into 4 by 3 into how much? 22 by 7 into 22 by 7. Am I correct? Yes, no? Yes. So from this I can get the values. Okay, so we have already calculated the value, no? So that value is 17.5 Newton. It's the correct answer. Whatever answer you have given, it's the correct answer. 17.5 Newton is the correct answer. Like approximately you will get 17.5 is the value. So the unit is Newton. So 17.5 Newton is the answer. Okay. So can we go for the next question? Okay, fine. So the next question, I'll try to zoom. Yes, no, it's clear. A body is projected vertically upward with velocity. So body is projected vertically upward with velocity. How much? 20 meter per second. If a potential energy of a body at 5 meter, I don't know the total height. Okay, I don't know the total height. The total height I will take it as h. But in this, at 5 meter, no, 5 meter, potential energy is equals to how much? It is 100 joules. 5 meter from the ground, it is 100 joules. 100 joules. So this height is 5 meter. Okay, this height is 5 meter. Then the kinetic energy of a body at a height 10 meter, at a height, let me take this height. The height is 10 meter. Okay, let me draw the clear diagram. Okay, wait a minute. So the thing is, this is the total height. Okay, total height. Object has been projected here with how much velocity? 20 meter per second. At height 5 meter, at height 5 meter, potential energy is equals to 100 joules, and they are asking at height 10 meter, what is the kinetic energy? This is the question. So when I project this object, if I reach the maximum height, the velocity will become 0. Acceleration is towards down, that is g, right. So from the kinematic equation, can I get the value of h? So what are the equations first? V square minus u square is equals to 2as, s is equals to ut plus of at square, and then yes, v is equals to u plus at, right. No, so in this, if I take the first equation, I can get it, right. V I know 0, u I know 20, a that is gravity, s that is maximum height, I need to get it. I can't use the second equation, t is there. Third equation is also I can't use, t is there. Okay, I need the value of h. So v square minus u square is equals to 2gh. 2gh. What is v square? Like, let me take this as, okay, this a, no, like minus g will come, 2 times of minus g into h. So v is 0, minus 20 square will be equals to 2 times of minus 10 into h. So minus and minus will get cancelled. This is 400 divided by 20 will be equals to h. 0 and 0 got cancelled 1 times, and this is 20 times. So the total height the ball went is 20 meter. 20 meter, right. No, so 20 meter, okay, fine. The energy I can find, no, potential energy at height, potential energy at height. Which height? Here the potential energy will be maximum, kinetic energy will be 0, because kinetic energy formula what it is, of mv square. So 0, velocity 0, kinetic energy also 0, but the potential energy at height, potential energy at h is equals to mgh. So what is mass? Okay, mass has not been given. How can we find that mass? This one has been given at height m. So P, potential energy at 5 meter will be equals to mgh, small h I will take. So how much? 100 will be equals to mass into gravity 10, height 5, right. No, so 1 times and 1 0 got cancelled, 1 2 times, so mass equals to 2 kg. Now you can substitute that mass, 2 into 10 into how much height it is? Yes, the height is 20, right? No, so simple guys, simple thing, the total energy I'll get it. Okay, so 2 into 4, 2 into 2 is 4 and 1 0 1 0, 2 zeros, so 400 joules. Total energy is nothing but potential energy plus kinetic energy. So total energy it is 400 because kinetic energy is 0, right? Now at height 10 meter I need to find it. Height 10 meter in the sense, potential energy at 10 meter will be equals to mass how much? 2, height 10, gravity 10. So how much it is? 10 into 10 is 100, 2 times 200. So at height 10 only, no. So total energy at 10 meter will be equals to potential energy at 10 meter plus kinetic energy at 10 meter. Total energy will be same throughout the motion, right? No. So it is 400 will be equals to potential energy is 200, kinetic energy I don't know, I need to find the kinetic energy. So kinetic energy will be equals to 200 joules. That's my answer. Which is the correct option here? So option 1 is the correct answer. Okay. So try to analyze that equation. Okay. You will get the answer properly. Okay. You can take a look of this question and we can go for the next one. Done? Yeah, the last step. Okay guys, we will go for the next question. So the next question here, two bodies of mass m and 4m, okay, one is mass m, one is 4m. If I take a 1m like this, 4m will be little bit bigger, right? Now if I consider this one, this will be 4, right? Now starts moving towards each other like this. Due to their mutual attraction, okay, the velocity of their center of mass, V center of mass, they are asking what is velocity of center of mass when the body attains a velocity V naught is. Try to understand one thing, initially the body is at rest, which means velocity will be 0, right? Initially the body is at rest, initial point v is equals to 0. V is equals to 0 in the sense, what about the momentum? Momentum is nothing but mass into velocity. When v is 0, momentum is also 0. Momentum is also 0, right? And when they starts moving each other, is there any external force acting? No. The first point initial v is equals to 0, momentum p is also 0, right? No, p is equals to 0. Okay. Second point, what it is? There is no external force acting on the body, which means object is going with a constant velocity, which means constant velocity. That's the second point. When there is no external force, no, it will go with a constant velocity, and the v center of mass also will be constant, velocity of center of mass also will be constant, that is 0 or okay, constant I will take right now. So when it is constant, then I can say that the body will be at rest only, right? So obviously the option will be 1, right now. You can take a note of this. We can go for the next question. Okay. So the next question, the angular velocity of a body changes from 6 radians per second to angular velocity omega is equals to 6 initially 6 radians per second to omega 2, which is 21 radians per second in time. Okay, in time 1.5 second, at 1.5 second. If the moment of inertia of a body, is 100 gram meter square, which is I will be equals to 100 gram meter square. I need to convert it into a proper unit weight, which is yes. So it is 0.1, okay, 0.1 kg meter square, 100 by 1000. Right now, so it's 0.1 kg meter square. Then the rate of change of angular momentum. What is momentum formula? Mass into velocity. Whenever we are talking about angular, like it will be in L, okay, fine. Angular momentum formula, like angular momentum symbol is L. Mass I need to convert it into I, moment of inertia. V, angular momentum omega. Right. So the rate of change in the sense, dl by dt will be equals to I into d omega by dt. Got it? So I, what is I? It is 0.1, and so it is, I can say that 21 minus 6 divided by 1.5 seconds. That's it. Simple. So I will multiply with this by 10, with this by 10. So it is how much? 15 by 15. 15 will get cancelled off. 1. Answer is 1 a Newton meter. So option 3 is the correct answer for this question. Option 3 is the correct answer for this question. Okay, can we go for the next one? Okay guys, so here is the question. If a displacement of a particle executing a simple harmonic motion is given by x is equals to 0.5 cos, yes, 0.5 cos 125.60, then the time period of oscillation of a particle is. So what this represent? This represent x is equals to a cos omega t, right? So from this I can say a is equals to 0.5, omega is equals to 125.6. Okay, I'll keep as it is this one. What is the time period of oscillation? It is nothing but t is equals to 2 pi by omega, right? No, 2 pi by omega. Now 2 into pi is 3.14. What is omega? 125.6. So try to calculate and give the answer for this question now. Yes, this is 6.28 divided by 125.6. So 2 decimals and 1 decimal. So can we take 628 divided by 12560? Got it na? So I can say 628 divided by 1256 into 1 by 10. I'll keep as it is this one. Try to give answer for this one. What? So 0.5 you are getting for this. So approximately 0.5 and divide by again 10. So we will get 0.05. So option is D. That's correct answer. Option D is the correct answer. Right? You will get a 0.05 as the answer for this question. Right now? Yes, you can take a look of this and we can go for the next question. Yes. Whenever they are giving like this kind of equation, try to compare that equation. So this is displacement equation, no. So displacement equation is x is equals to a cos of omega t, right? A cos of omega t. What is a? Amplitude, right? No, the maximum displacement happened. Yes, like the each end. And what is omega? Angular velocity, t time, and x is the displacement. So when we talk about the velocity, so when we differentiate x, I will get velocity. I will take a as it is. Cos differentiation is yes. Sin it will be cos. Cos will be minus sin. Okay, fine. I will keep minus. Yes, no, minus no. Okay. V will be equals to a sin of omega t into omega. I will keep that minus and plus as it is. I will do it later. I will try to complete this equation first. Okay. Next, acceleration, if I want a omega, I will keep as it is. Again, sin will be cos of omega t, and again the omega will be there. So that is square. So this is minus and this is also will be minus, right? Now if you look in this equation, I will rewrite this. A is equals to minus omega square into a cos of omega t. Is this looking like the first one, x? Yes. So a will be equals to minus omega square into x. Is this equation you have looked right in IP equation? Yes. IP point of view, you would have got this equation. What is the acceleration of the oscillation? So minus omega square times x. X is nothing but the displacement. What is x? A cos of omega t. Got it? So that's the thing we have applied here. Okay. Whenever they are giving a velocity equation also, I need to take this equation, try to compare it. Whenever they are giving acceleration equation also, take that equation and try to compare it. Okay. So don't blindly apply that conditions. Okay. Try to analyze what's the thing they have given and then try to apply the conditions. Okay. So done. Can we go for the next question? Okay guys, we'll go for the next question. Yeah, here is the question. Escape velocity, okay, from a body of from a planet of mass m and radius r is 14 kilometer. What is escape velocity formula? V is equals to root over 2gm by r, 2gm by r. Okay, this is the formula. I will write the condition of a planet they have given. Escape velocity for other body from other planet, okay, like of a body from another planet having a same mass but diameter is 8r, diameter 8r they have given, okay. So what is the escape velocity they are asking? Let me write the condition first. So two conditions I will take. Planet 1, planet 2. So for planet 1, V1 will be equals to root over mass is m, radius is r, okay, 2gm by r, how much? 14 kilometer per second. So I will write as it is, I will keep this one as it is, okay, no need to do anything, okay. Now the next one, velocity of the planet 2, escape velocity of the planet 2 will be equals to root over 2g, what is m? M is same, keep m as it is. Radius they have given, sorry, diameter they have given, radius is the thing I need to take it. So diameter d is equals to 8r, then radius will be divided by 2, no? So r will be equals to d by 2, which is equals to 8r by 2, right? No? So can you give answer for this question now? First. Yes, so it will be how much? 4r. Okay, fine, 4r. Can I take that 4 something like this? Root over 1 by 4 into root over 2gm by r. Correct? No? Correct? No? So what is the thing? This is 1 by 2 will be equals to root over 2gm by r. So what is root over 2gm by r? It is 14. So it is 1 by 2 times of 14 kilometer, which is nothing but 7 kilometer per second. So this is my velocity of the second planet, the other planet. How much? Option 1. Option 1 is the answer for this question. Option 1 is the answer. we go for the next question? Okay. So next question. Yes, like the graph, I will give the graph, okay. Sorry for the graph, okay, I will give the graph here. Okay, there is the thing. Wait a minute, let me take the angles. See, this is A and this is B, this is 30 degree and this is my 60 degree. So they are asking what is the Young's modulus of a material of A and B. Stress versus strain, na? Stress and strain, opposite by hypotenuse. Stress and it is strain. So what is the relation? So when we talk about the stress and strain, the relation of Young's modulus is nothing but stress by strain, opposite by hypotenuse. Tan theta, right? No, tan theta, the slope. So YA will be equals to tan 30 degree, which is nothing but YB will be equals to tan 60 degree, which is nothing but I need to get the answer for this. So simple, YA by YB. Give answer now fast. Yes, so it is 1 by root V. Okay, what is this? YA 1 by root V, YB root V. So yes, this is 1 by 3 I will get, right? No, so YA by YB will be equals to 1 by 3, where Young's modulus of B will be equals to 3 times of Young's modulus of A. So which is the correct option? Option A, YA will be equals to 3, YB, no, neglect it. YA will be equals to YB, no, YB equals to 3 YA, yes, this is my option correct. YB equals to 2 times, no, neglect this fourth also. Option B, 3 is the correct answer for this question. Got it? Right. Can we go for the next question? Yeah, you need to know the sine, cos, tan values, everything. Simple, no. Sine, I will write the values. If I write in the reverse order, I will get the cos value. So tan is nothing but sine by cos, right? No, if you know these three, cosecant, secant and cot will be easy, like reverse of sine, cos and tan. Okay. The next question. Rectangular slab consists of 2 cubes, that is copper and brass. So copper, brass of equal side having a thermal conductivity of so thermal conductivity of copper is 4, thermal conductivity of brass is 1. If free space of a brass is 0 degree and the copper maintains at 100 degrees Celsius, the temperature of their interface is simple formula, no? What is the formula? Q will be equals to K times of or K into delta T by L. Can I write now? So K delta T by L, okay, or I can write the formula as K1 TH minus T, like what is the common temperature we'll use, okay, TC, okay, right, or else I can take the common temperature as T. What is TH? The high temperature divided by the length will be equals to K2 T minus TC divided by L, L1, L2, A1 and A2 also there, like A1 and A2, right? No, A1 and A2, but areas are same for the given things and length also same, only the remaining thing 4K TH. TH is nothing but high temperature, that is 100. TC is nothing but low temperature, that is 0. T is nothing but the interface I need to find, right? No, So 100 minus t, length is same, will be equals to k into t minus 0, right? K will get cancelled. 400 minus 4t equals to t. 400 will be equals to 5t. T will be equals to 400 divided by 5. 1 times and this is 8 times. So temperature will be 80 degrees Celsius. What is this temperature? Interface. The temperature of interface of the copper and the brass. Copper and the brass is how much? 40. Sorry, 80. Correct, no? 80 only. We have done correct only. Yes, 80. That's the answer for this question. Right now? Okay. So, with this we'll complete the questionnaire session of the today's class, and we'll start with the next topic in the next upcoming classes. Okay. So, thank you guys. We'll meet in the next class. Until bye bye.